Welcome to the lesson on solving rational exponent equations. Now, here's what I mean. I mean equations where the variable is in the exponent. So let's get right to it. The main principle that you will need to be aware of is that when the bases are the same, then the exponents are equal. And so if you have an equation with exponents in the variable and the bases are equal, you can eliminate the bases and just set the exponents equal and solve for the variable. Let's go right into an example. In this example, we have 4 to the third power is equal to 4 to the x minus 2 power. Now, in these cases, the bases are equal. They are both 4. And so we can set the equation, the exponents equal to each other. And you notice I have eliminated the bases. I set the exponents equal to each other, and I'm going to solve for x. I will do this, in this case, by adding 2 to both sides, and I end up with x is equal to 5. I do need to check my work and make sure that I have a valid solution. So I'm going to substitute 5 back in for x in the original equation and make sure that I end up with the same value on both sides of the equation. This solution is valid. Pause now and copy everything you see in this screen. Alright, let's take a look at example number 1. It is 5 to the 2x plus 2 power is equal to 625. Now this is very typical. Now the bases are not the same. What do I do now? I'm going to factor 625 and see if I can rewrite that in terms of 5 to the something power. When I factor 625, I find out it's actually 5 times 5 times 5 times 5, which is 5 to the 4th. So I'm going to replace 625 with 5 to the 4th. Now, the bases are the same, so I can set the exponents equal to each other and solve for x. I will do that by subtracting 2 from both sides and then dividing both sides by 2. And I end up with my answer of x equal 1. But wait, I'm not done until I check my work. So I'm going to substitute 1 in for x in the original equation and make sure that I get 5 to the 4th or 625. In our next example, our exponent is a little bit more complex. It's a fraction. And we see that the bases on both sides of the equation are not the same. So I'm going to factor 6 and see if I can write that in terms of 6 to the something power. You probably have already guessed that I'm going to write it as 6 squared because 36 is 6 times 6. So now I have a base of 6 on both sides of the equation. I can set the exponents equal to each other and solve for x. In this case, I'm going to start by multiplying by 2 and then subtracting 5 from both sides, and I get x is equal to negative 1. Remember that you need to check your answer, and so I'm going to substitute negative 1 back into the original equation every place I see x, and I'll end up with 6 to the negative 1 plus 5 divided by 2 power is equal to 36. When I simplify that exponent, it's 4 over 2. And when I simplify that, 4 divided by 2 is 2. And we know that 6 squared is equal to 36. And so my solution is valid. Pause now and copy down this entire example. Our last example is this. 2 to the 8th power divided by 2 to the x plus 1 power is equal to 32. Now, of course, 32 is not a base of 2, so I'm going to factor 32, and I will find that 32 is 2 to the 5th power, so I'm going to replace 32 with 2 to the 5th power. But I still don't have bases that are the same on each side. But if I apply the quotient law of exponents on the left side of the equation, right here, the quotient law says that this is equal to 2 to the 8th minus x plus 1 power. And at that point, I have the same base on both sides of the equation. And so I am going to set the exponents equal to each other and solve for x. I will begin to do that by distributing the negative sign across each term in the parentheses. That gives me 8 minus x minus 1 is equal to 5. I'm going to combine 8 and negative 1, like terms. Now I'll end up with negative x. I have a typo here, but I'm going to go on. Negative x minus 7 is equal to 5. I'm going to subtract 7 from both sides. That should read negative x plus 7 is equal to 5. Again, the previous line right here should read negative x plus 7 is equal to 5.